In our last two lectures, we've really been talking about minerals and getting into the nitty-gritty of minerals and what makes a mineral, and really looking at the chemistry of minerals being the essential portion of minerals, giving it its solid appearance, making sure that it's inorganic, and creating these wonderful crystal structures that we've been seeing and going through, looking at cleavage and cutting open some rocks or knocking them open, seeing how these crystals continually will break at the same spot all of the time. But there are other properties that this chemistry gives us. And chemistry will also give us some things that we can test or see or look at that's interesting about minerals. One of the first ones, one of the easiest ones to look at is hardness. Hardness is the resistance of a mineral to scratching. Mohs scale of hardness. Mohs is a responsible scientist who came up with this way of classifying minerals, based on their hardness. So Mohs scale is a standard of 10 minerals by which these hardness other minerals are placed against or tested against. And you'll see that there is a chart right here that tells us the Mohs scale of hardness. So diamond is being the hardest, and it is given the radium number 10. The lowest being talc, which you all know as chalk, and it's pretty soft, and we can pretty much, there's not what you have to do or pressure you need to apply in order for it to break or crumble or scratch. Okay? So when we look at hardness, we're looking at this mineral's tendency to scratch. Do we have to do a lot to make it scratch, or do we have to do very little to make it scratch? So we use common things such as our fingernail, which will give us a hardness of about 2.5, meaning if that mineral scratches with our hardness, with our scratching with our fingernail, it's not very hard. When we have a penny, let's say a penny can scratch this mineral, then we have a hardness of about 3, and we're looking at a mineral calcite, one that you guys are familiar with because that's one that we are breaking open. And then we have a knife blade. If we can scratch a mineral with a knife blade, that is a 5.5. Okay, and so that's going to fall somewhere in here on the scale of hardness. Another way we look at minerals, and a property that elements will give us in these minerals, is luster. And luster is really the look at the reflection of light from the surface, meaning how shiny is this mineral going to be. We have one example here that is showing us one that is pretty dull. It's earthy looking, and that generally will mean that these minerals are very porous and it's allowing a lot of the light to just kind of come in. We have one right here which is extremely shiny, has lots of luster to it. The elements are probably packed in pretty tightly, and there's not a lot of pores, and so the light is being reflected back off of this mineral, giving it its very shiny appearance. Down here you will see that there is a chart, and we actually, scientists or geologists go through and they use some common words such as dull, waxy, oily feeling, pearly looking, metallic looking. Okay? These are words that are used to describe minerals. And the description that goes behind something that's metallic, for example, is that it's very shiny. It likes, metals are highly reflective. There are opaque minerals there. And then they give us examples of minerals that fit this descriptive word of metallic. So for example, pyrite, known as fool's gold, gold and silver. Okay? We have, all the way up here, we have then the dull and the earthy. And obviously dull means dull. But these minerals are porous, and that means that light can go through it and not be reflected off. Then it gives us some example. We have orthoclase right here, of a mineral that goes through it. I would like for you can always stop the video at this point and you can look at this, and I would like for you to look at this chart and kind of familiarize yourself with it a little bit. Obviously these videos will be here for you to look at later on too when we start going through it, but just kind of read over this chart for a couple minutes and get an idea so that when we start to use, I'm going to be looking for these words to be used in our next lab that we're going to do. Another property that we have is the streak, a streak test, okay? And the streak test is basically the color of a mineral in its powdered form. We usually see this by striking a tile, a white tile, seen in the picture here. And this white tile then is not glazed, so it allows for us to take the mineral, streak it across this plate, hence why it is called a streak plate. Okay? And when we do that, we put the mineral in its powdered form along this plate, and we can see what color comes up. Certain colors will appear for certain minerals and then these minerals can help us figure out kind of what elements are in there, because every element has a certain color associated with it. So for example, in this picture right here, we have hematite being scratched along this scratch plate, and it's giving us a red-brown streak to it. That is a property that is semi-unique to hematite. Okay? Another property that we have, and this one is probably the least reliable property of them all, is color. Okay? And color is really dependent on the impurities that are present. So this is really unreliable to us. So we could have this mineral called corundum. And basically it's aluminum and oxygen put together, okay? Now this mineral can appear in two different colors, okay? Depending on the different other impurities that are in there besides aluminum and oxygen. Okay, so we can tint this, can come up to the color red if we have chromium, the element chromium also mixed in with aluminum and oxygen. And these we would know as rubies. Okay, we can also take the same mineral, aluminum and oxygen, and we can have it be tinted blue because there are small amounts of titanium in them, and that element titanium gives it its color blue, and we call these sapphires. So right here is my picture of rubies. This is rubies that you would probably see in any type of jewelry, and this is a raw ruby. What it would look like coming out of the earth. We also then have, here are the sapphires. This is obviously the jewelry one right here, and here's sapphire in the raw before it is made and polished and made it to look very beautiful for our jewelry. We also have other properties that are specific and unique to certain minerals. So for example, when we have metals that are inside of, or are part of our mineral, we have a good conductor of electricity. So this is our coppers, our aluminums, our brasses, any sort of metal that we use to distribute are really good for conducting electricity. Again, all of this stems back to the chemistry of a mineral and the ions that are present. We also can take some of our minerals that have a carbonate in them, and they will actually fizz when we put a hydrochloric acid on them. So here's an example picture right here of when we have hydrochloric acid and we're dropping it on a mineral that has some carbonate in it, and it will fizz. And that tells us that carbonate is present, and then that will help us to kind of narrow down what mineral we are talking about. A few minerals are radioactive. Very few, but there are some, and that means that they are releasing subatomic particles and radiation in the unstable atom that's decaying within them. So uranium is one of these. That uranium will start to decay, and it's going to release some unstable atoms with it, and so it becomes radioactive. Some minerals, like magnetite, magnetite is a very fun mineral to play with because it is magnetic. Which means, if we look at this picture right down here, this means that we have the ability for magnets to stick to it. So we could add metal things such as paper clips to it, and it's going to stick. Okay? And that is because it has a good amount of iron inside of it. We also have some that are fluorescent. And they have, when we hit them with some ultraviolet light, we can have it become fluorescent. So this picture right here shows that it is glowing in the dark, which is very, very cool. And then we have a few minerals that will actually store light. So it sits out in the sunlight and it captures all of the light energy during the day, and at night it will release it in something called a photophosphorescent. Okay, and here is a picture of some different minerals that actually will do that and also glow at night.